What's going on, everybody? Got another video here, statistics video. This is on binomial probabilities. Now I'm going to do this video. This is on binomial probabilities, and I will have another video right after this one on, let me see, it's kind of like a continuation of this one. It is additional properties of the binomial distribution. So we'll actually work some more problems and we'll work more examples and some different examples. So basically this video and the next video, binomial probabilities and additional properties of the binomial distribution. That's, I guess you could kind of say they're gonna kind of go together. So let's get started on this one. All right, so features of a binomial experiment. Oh, and before I get started, the link to the video after this one where they kind of go together, I'll put the link of that video in the description. All right, so features of a binomial experiment. There's a fixed number of trials, and we denote the number by the letter N. So you're going to have a fixed number, say like, I don't know, flipping a coin. You're going to do it 50 times. N would be 50, okay? And you're going to record whether you get a heads or a tails and that kind of stuff. Well, or you're going to see if you get a heads or not, okay? The N trials are independent and repeated under identical conditions. So in other words, the N trials, they're independent. That means if I do one trial and then I do the second trial, the first trial has no effect on the second trial, and the second trial has no effect on the third trial, and so on. And we have to do them under identical conditions. All right, so each trial has only two outcomes. Okay, it's either going to be a success or a failure, and we represent a success with the letter S and a failure with the letter F. So in other words, if we flip a coin, we want to see, do we get a heads? So we either get a heads or we don't. If we get a heads, that would be a success. If we don't get heads, that would be a failure. Okay. For each individual trial, the probability of success is the same. Okay. We denote the probability of success by P, the letter P, and the probability of failure by the letter Q. Since each trial results in either success or failure, P plus Q is equal to 1. Okay, because let's just say it's a 60% chance that you get a success. Say the success is 0.6. So then that means the probability of failure would be 0.4. And if you add those together, that would give you 1. So if you do know the probability of success, you can get the probability of a failure, Q, by doing 1 minus the probability of success. So if the probability of success is, say, 0.6, that's P, probability of success, then the probability of failure would be Q equals 1 minus P, which is 0.4. That's what that's saying. And then the central problem of a binomial experiment is to find the probability of R successes out of N trials. Okay, now I'll explain that one more as we're working the examples. All right, so let's get started with some examples to work. All right, so analyze the binomial experiment to determine P, Q, N, and R. So in this one, we're not finding probability. We're just going to learn how to identify the probability of success, the probability of failure, N, the number of trials, and R, the number of successes that we want. So it says, according to data, 9% of the population has blood type B. Suppose we choose 18 people at random from the population and test the blood type of each. What is the probability that 3 of these people have blood type B? All right, so like I said here, we're not going to find the probability because we don't know how to do that yet. We don't have a formula. Okay, we need the formula, and we're going to get that in the next example. And then there's another way that we can calculate probability by using a table, and we're going to do that also. We're going to use the formula, and we're going to do a table. And I'll explain to you why one's better than the other. Okay, or, well, not better, but easier to use than the other. All right, so what does it say? According to data, 9% of the population has blood type B. Okay, so the probability of success, well, let me change colors. The probability of success, which, remember, probability of success is denoted with the letter P. So what is that probability? Well, it's 9%, right? It says 9% of the population has blood type B, so that would be 0.09. And so that means the probability of failure, Q, that would equal 1 minus 0.09, which would equal 0.91. So there's the probability of failure. There's the probability of success. So we've got P, we've got Q. Now, what about N? Well, remember, N, that's the number of trials. Well, what does it say? Suppose we choose 18 people. That's how many people we're going to do a trial on. So that's 18. And then what is the probability that 3 of these people have blood type B? So remember, R, we got N, so R is the number of successes. Well, how many successes do we want? Well, we want 3 to have blood type B. So R is equal to 3. And that's really, that right there is the most important part, is being able to identify P, Q, N, and R. Okay, and once you get those, then you just pop everything into the formula, and you can create and you can calculate the probability, which that's actually what we're going to do here in just a second. We're going to get the formula. Yep, here it is. All right, so here's the formula for the binomial probability distribution. So the probability of R successes is n factorial over R factorial times n minus R factorial times P to the R times Q to the n minus R. Or you can write it as this. So you can see here that we have this part of the formula, which is right here. And then this part right here, this part right here, all that is combination N choose R. That's all it is. If you remember back when you studied permutations and combinations, that's all it is. It's combination N choose R. And remember, that's the formula for combination. So really all you need to look at is just this right here. Okay? Because, I mean, yeah, if you're punching it into a calculator, you can use this formula to punch in combination. But remember, most calculators, the scientific, well, pretty much every calculator, scientific or the graphing calculators, they have, the calculator will calculate combinations for you. So you can just, do the combination in your calculator. Okay, so N is the number of trials. P is the probability of success of each trial, and R is the random variable representing the number of successes out of N trials. So we learned how to identify all that up here in the previous example. All right, and R is going to be between 0 and N. R is not going to be more than N. It can equal N, but it's never going to be more than N, and it's not going to be less than 0. You're not going to have a negative successes. All right, so let's take a look at this example. We're going to find this probability, and we're going to use the formula. Okay, so it says privacy is a concern for many users of the internet. One survey showed that 59% of internet users are somewhat concerned about the confidentiality of their email. This should be based, there should be a D there on the end. Based on this information, what is the probability that for a random sample of 10 internet users, 6 are concerned about the privacy of their email. Okay, so, here's your formula right here. So, we need to identify N, P, Q, and R. All right, so we get N is equal to, okay, so what would N be? So, well, it says what is the probability that for a random sample of 10 internet users, so that's how many trials we have, we've got 10 total, 6 are concerned about the privacy. So that's the number of successes, because that's what we're looking for. How many are concerned with their privacy? If they're concerned with their privacy, that's a success, because that's what it's asking us to find. And so we get R is equal to 6. The probability of success, P, well, what would that be? Well, it says one survey showed that 59%. So that's 0.59. Okay. And then Q is equal to 1 minus 0.59, which is equal to 0.41. So we've got everything we need to plug into our formula. So we've got the probability that R is equal to 6. Now let me say this. In this book that I teach out of, they use R here, okay, for the probability of success. Some books use the letter X, okay? It doesn't matter what letter you use. They're both the same thing. Some books use X to represent the number of successes, and some use R, okay? All right, so this is equal to, well, look, just plug everything into your formula. So that's combination 10 choose 6 times P raised to the R. So that's 0.59 raised to the R times Q, which is 0.41, raised to the N minus R. So that's 10 minus 6. And then, you'll have to punch all that into your calculator, and you end up getting about 0.25. Now, I didn't plug this into my calculator. I just got the answer out of the book, so I don't know. That may be rounded to 2 decimal places, but that's your answer. Well, actually, they have the answers. If you plug it into your calculator, you get 0.250342. That's a 2. 4245. Okay, and then you round it to 2 decimal places. I don't know how many decimal places your teacher wants you to round it to, 2 or 3. Usually when I'm dealing with probability, I'll have them round it to 3. But if you round this one to 3, you'll get 0.25 anyway. So, but yeah, there's your answer. That's all it is. Like I said, the main thing is identifying N, R, P, and Q. And then you just plug it in. Now, as far as punching this combination into your calculator, just depends on what calculator you have. So I can't really tell you because I don't know what calculator you have. I do have some videos. You can search my channel, calculator combinations. Search it for that and it'll probably pop up. I think I have a TI-30X2S, how to do it on that, and I think a TI-84 Plus. I think I show how to do it on that one too. So you can, the big TI graphing calculators. So just check my channel out for that. You'll see how to punch that in. All right. All right. Using a binomial distribution table. All right. So now we want to use a table. Okay. And what would be the benefit of using the table versus using this formula here? Well, let me show you. So if we want to use a table, and I've got a table, I'm going to pull it up in just a second. But the probability for 4 or fewer successes. So the probability of 4 or fewer excesses is the probability that R is less than or equal to 4. Okay, 4 or fewer successes. All right. So that means, okay, 4 or fewer. So that means we could have 0 successes, or we can have 1 success, or we can have 2 successes, or we can have 3 successes, or we can have 4 successes. And notice here they tell us n is 6 and p is 0.5. So look at this, p equals 0.5, and so we also know q is equal to 1 minus 0.5, which is 0.5. But when you're using the table, you don't need to know what q is, okay? But let me show you what would happen if we use the formula that we just had. So if I use the formula, look at this. You see where p is 0? I would have to plug that in to this formula here. You see that? And calculate that. Then I would have to do it for when r is equal to 1. I would have to plug that into there. In other words, you see what I did here? I would have to do that for each one of these. So I would have to do it 5 times. And you can imagine how long that would take. So that's where the table comes in handy. So let me pull up a table. Now the table that you have may not look exactly like this one, okay? And that's fine if it doesn't, but it's all the same concept. All right? So we want to know probability r is less than or equal to 4. Okay? N is 6, p is 0.5. So let's pull up the table. So we've got, what we have is we have the probability that r is less than or equal to 4. We have n is equal, I think it was 6, wasn't it? Let me check. Yeah, n is 6 and p is 0.5. All right, and we've got p is equal to 0.5. All right, so let's show how to do this. Now this table I've got, they've got, you see the x here? Okay, for us that's an r. Okay, just like I said, some books are going to use an x, some are going to use an r. So whether this is an x or an r, you treat them the same. Okay, all right. And so notice this column here, this n column. That's your n. See, we got 2, 3, 4, 5, 6, 7, and it goes on down to 8. Now, I'll probably have a table in the next video that goes up to 20. N goes up to 20. I might use a different table. All right. So let's kind of increase this a little bit. I don't want to increase it too much because I want to make sure I can get all this in here. About right there, maybe. All right. So the way we look this up, all right, so remember, we've got to get the probability 0 plus the probability of 1 plus the probability of 2 plus the probability of 3 plus the probability that r equals 4. So we got to do all of those. So this is it. So you look at your n is 6. So that means we are in this section right here where n is 6. This section right here. That's the block we're looking at. All right? And that's from this number over here in the far left column. All right. Now, we've got a probability of 0.5. You see the p up here? Here's your column for p is 0.5. It's this whole column here. Okay? But keep in mind, all we're concerned with is just this part of it. Okay? Because we're in this block. And so we want to know the probability that r is 0. Well, you come to this column here and look at this. You see where r is 0? You come over to where p is 0.5 and it's this. 0.16. So that's going to equal 0.16 plus, and then when R is 1, so R is 1. Now keep in mind, you've got to be in this section where N is 6. So that's going to be 0.094. I'm having a little trouble seeing those little numbers. So I hope I don't write them down wrong. And then the probability P is 2. So we come here to the 2. That's 0.234. 0.234 plus, and then probability P is 3. So we come here, 0.312, 0.312 plus, and then probability where R is 4. So we come to the 4, and we come over, that's 0.234, 0.234. And then when you add all of those up, let's see, do I have an answer here? Yeah, that's going to be 0.894, 0.894. And there's your answer. Okay. And that's, that's all there is. That's all there is to it. That's your answer. All right. So that's the benefits of using a table. It's a lot quicker. You don't have to punch everything into that formula. You just look the numbers up, what you want. Okay. All right, so let's do another example. I'm going to erase this. We'll have another example where we use the table again. So I'm going to erase all this so we can write over here on our next examples. All right, so what did we get? We got 0.890. Okay. All right, let's move right along. All right. And actually, this is the last example. So how about right now, you pause the video, you try to work the problem, and then when you get finished working it, play it, and you can watch me work it. All right, so it says a biologist is studying a new hybrid tomato. It is known that the seeds of this hybrid tomato have probability of 0.7 of germinating. The biologist plants 6 seeds. What is the probability that exactly 4 seeds will germinate? And then what is the probability that at least four seeds will germinate? All right, so part A, part B. All right, so for part A, let's go ahead and identify N. Okay, so the biologist plants 6 seeds. So N is 6. The probability of success, so we want to know the probability that the seeds will germinate. So that's the probability of success. So that is 0.7. And we're going to use a table. So we don't need to know what Q is, but we can go ahead and find it. Let's do it anyway. 1 minus 0.7 is 0.3. And then let's see, in this case, what is the probability that exactly 4 seeds will germinate? So we want to know the probability that R is 4, and that's 4 exactly. Now you can write it as probability 4, or another way you could write this, probability R equals 4. Or if your book uses X, the probability X equals 4. All right, it's however. All right, so we've got N equals 6, and the probability of success is 0.3. It's 0.7, and it's when R is equal to 4. So let's come over here. N is 6. Okay, N is 6, so that means we are using this block right here. P is 0.7, so it's this column. See that? And we want to know when R is 4 exactly. So we're on this row right here. So it's that one right there, 0.324. So this is 0.324. There's your probability of success. Okay. All right. So it's that it's a lot easier when you're using the table. Okay. And stay tuned for after this problem so I can explain something else to you. Sometimes that table's not going to always work, and I'll explain that in a minute. So what is the probability that at least 4 seeds will germinate? So that's the probability that are at least 4. So that means it could be 4 or 5 or 6. So that's the probability that R is greater than or equal to 4. So that's the probability that R equals 4 plus the probability that R equals 5 plus the probability that R equals 6. Okay. All right, so we just look up the 4, 5, and 6. We already looked up 4. That's 0.324. Plus, now the probability that R equals 5. Let's see. Let me erase that. That's this one. There's 5 right here. So it's this one right here. It's 4, 5, and 6. Those 3. 0.303. Oh, 0.303, 0.303, and then we look up the 6, 0.118 plus 0.118, and when we add all those up, we get 0.745. So there you go. All right. Now, that's kind of basic. Now, and one thing I do want to point out on this table, and this is going to come in handy in the next video. Okay. Do you see all these little blocks of numbers right here? Each one of these, like this set of numbers here, they add up to 1. This set of numbers here, they add up to 1. This right here adds up to 1. These add up to 1. These add up to 1. Each little section there, not the whole entire section, but each little individual column in the sections, they each add up to 1. Now, if you add them all up, I don't know, they should add up to 1. Some of them may add up to 0.999 or 1.001, something like that. If that's the case, it's just because of rounding. Okay. And then the next thing I want to mention is sometimes the table's not going to always work. What if you had a problem where n is equal to 50? Okay, n is 50, or n is, or let's say n is 18. Okay, n is 18, and your probability of success is 0.53. Okay. Well, you might find a table where n is 18, but what about the p up here? There's not a 0.53, so the table's not going to do you any good. And, if n is 18 and they want to know what's the probability that r is greater than or equal to 10, well, do you want to punch that into the formula where r is 10 or 11 or 12 or 13 or 14 or 15 or 16 or 17 or 18? You don't want to put that in the formula either, but you're not going to be able to use the table. So what's your other option? Well, your other option is to use Excel spreadsheet. Use Excel, Google Sheets, use a spreadsheet. Okay. Now, I'm not showing you how to do that in this video, but I do have a video where I do that. Just type in binom.dist. Search that on my YouTube channel, and I show you how to do this in Excel. Okay, how to find these probabilities. So check that video out. All right, so I think that is all for this section. Like I said, the next video will be kind of like a continuation of this. Okay, I'll have the link in the description. All right. So I hope this video helped. Check out my other videos. Give me a like, share, subscribe, comment. Thanks for watching, and I'll see y'all in the next one. Later.